Good morning, everyone. My name is Anurag. Today we are going to discuss about the PPM, pulse position modulation, in this session. So already we have seen the previous concept called as an pulse amplitude modulation and pulse width modulation in the previous videos. Now we can identify the third type of a modulation technique, pulse modulation technique called as an pulse position modulation. So what is PPM? Pulse position modulation is an analog modulation scheme in which the amplitude and the width of the pulses will remain constant, but only the position of each pulse is going to vary with respect to the message signal. Here, in order to perform this pulse position modulation, the transmitter has to send synchronization pulses. These synchronized pulses are used by transmitter and receiver to maintain synchronism. PPM can be done in accordance with the PWM signal. That is, in order to generate a PPM signal, first of all we have to generate a PWM signal. This PWM signal is generally given to a monostable multivibrator, where this PWM is used as a trigger signal based on the condition whether it is going to follow the trailing edge or leading edge or center of the on time. One of the edge is kept as an synchronizing pulses. Whenever this multivibrator identifies the trailing edge, for example, in the given diagram we have drawn the PPM signal with respect to the trailing edge of an PWM signal. So whenever the trailing edge of PWM signal is obtained, this monostable multivibrator will become active and it moves to the on position and maintains in the same position for a short duration and again come back to the off position. That is, initially the monostable multivibrator will be in a zero position until unless it identifies the trailing edge of a PWM signal. Once the PWM signal is identified, it becomes on for a short duration and again it becomes off. Similarly, the same process goes on for the consecutive cycles. Thus, a PPM signal can be generated from the PWM signal using a monostable multivibrator. Thus, finally, the position of these pulses is proportional to the width of the PWM signal. We know that the amplitude of the message signal will define what the width of the PWM signal. That is, indirectly the PPM is also varying its position based on PWM. That is, indirectly depends upon the amplitude of the message signal. So what is the advantage? So already we have seen something called as in PWM. Then why for going to this PPM signal? The main advantage is that the amplitude and the width of this PPM signal is constant, so that with the help of this constant amplitude, the effect of noise can be reduced. By reducing the width of this PPM signal, we can handle the power. Power can be saved. Disadvantages are maintaining the synchronizing between transmitter and receiver is somewhat difficult task in case of an PPM signal. If we are able to maintain this synchronism, it presents better output. So the process of generating a PPM signal can be explained here. So the PWM signal is differentiated and the differentiator output is rectified and shaped so that a position or a pulse can be identified which corresponds to the trailing edge of the PWM signal. And this rectified signal is given to monostable multivibrator. Whenever this pulse is being identified by the monostable multivibrator, it places a single pulse at that corresponding position. The transmitting of these very narrow pulses requires a large bandwidth, and this type of modulation technique is suitable for transmitting analog signals where it uses light as a source. That is for LED and laser transmissions, ppm signal is highly used. So if we see the bandwidth considerations, bandwidth for transmitting a ppm signal should be greater than the transmission time. Both the PWM and ppm has the same amplitude or same DC value. It has to identify the sharp rise time and fall time to preserve the message information. As the message itself is going to be waited for the shorter time, we have to maintain this rise time and fall time. Bandwidth required for PAM is higher than the ppm. So these are what the differences here. PAM, the amplitude of the pulse is proportional to the amplitude of the modulating signal or message signal. Bandwidth of the channel depending upon the width of the pulse. Instantaneous power of transmitter varies because amplitude is going to be affected by the noise. Therefore, noise interference is high. So power requirement is also going to be vary. It is somewhat complex system. It is generally similar to an amplitude modulated system. Next is PWM. The width of the pulse is proportional to the amplitude of the message signal. Bandwidth of the transmitting channel depends upon the rise time of the pulse. Instantaneous power of the transmitter varies. So here, even though the amplitude is kept constant, the width of this PWM signal is varying and noise interference is less. So power transmitter is also slightly varies. It is similarly to implement FM. And coming to ppm, relative position of the pulse is proportional to the amplitude of the message signal. Bandwidth of the channel depends upon both rise time and fall time of the pulse. So as it maintains the short time, we can say that rise time decides the bandwidth requirement. Power is constant, noise interference is minimum. It is similar to phase modulation. So it is an differentiating the PAM, PWM and ppm for various parameters. So in this, all these three techniques, PAM, PWM and ppm, type of carrier used is pulse train of pulses. And the variable characteristic in PAM is amplitude and PWM is width, ppm is position. Bandwidth requirement for PAM is low, PWM is high, ppm is also high. Noise and information contained in amplitude variations, width variations, position variations, and power efficiency, that is signal to noise ratio, and similarly low, moderate and high. Transmission power varies and constant. Synchronizing pulses is not required in PAM, PWM, but it is required in ppm. Bandwidth depends upon the amplitude of the pulse, rise time of the pulse. Transmitter power varies in case of both PAM and PWM, whereas in ppm its power is constant. Complexity is, that is generation and detection of a signal, is easy in case of PWM, but whereas in case of PWM and ppm is somewhat complex. And these are similarly to AM, PM and AM, FM and PM. These are what the some differences between the three types of pulse modulation techniques. Thank you.